All right, so transforming data review. So this is actually something that we've already done before, right? So I think that the packet that I sent out to you guys had a few typos that I fixed. So this should say mean and median instead of 5-number summary, so just change that to median. And then this whole box should say does not change. Sorry about those typos. Okay, so our big review is that we know that measures of center change no matter what. So whether or not we're adding, subtracting, or multiplying or dividing, your measures of center are definitely going to change. Now your measures of variability, or your measures of spread, will change if you're multiplying or dividing. If you're adding or subtracting, it does not change. So these 4 pieces we've already discussed before, even if you don't remember it. So the measures of center are changing when we change every piece of data in the distribution by the same amount, either multiplying, dividing, adding, or subtracting. The measure of spread only changes if we multiply or divide, not if we add or subtract. And then more recent things that we've learned about, measures of location, our percentiles and z-scores, they're not going to change, because they tell us the location relative to the rest of the data, so that doesn't change when I change every single number in the data set. Shapes of distributions also don't change. So if it was symmetric before, it's symmetric after, when I multiply every number by the same number or subtract every number in the data set by the same number. So you can reference this chart up here to know what changes and what doesn't. So multiplying and dividing measures of center always change. Measures of location and the shape never change. And then our spread only changes if we're multiplying or dividing, not adding and subtracting. All right, so let's go ahead and do some examples. These are from the Khan Academy that you were assigned, so hopefully you'll be able to use these same answers on the Khan Academy. All right, example 1. The distribution of heights of 12-year-old boys on Tim's rugby team had a mean of 150 centimeters and a standard deviation of 10 centimeters. All right, so you might see this written like this: mu of 150, sigma of 10. Mu of 150, sigma of 10. What will the mean and standard deviation of the distribution of heights in feet? 1 centimeter is approximately 0.033 feet. So it's asking us to convert this, meaning that I'm going to multiply every single number in the data set by this. So if I'm multiplying, so let's think about this. If I'm multiplying, my measures of center and spread both change. So all I need to do is multiply the mean and the standard deviation by this 0.033. All right, so and my sigma all right. That's it. So remember, when I'm converting units, I need to multiply, and multiplying changes both my center and my spread, so they both change with multiplication. If we were adding or subtracting, only the measure of center would change. The measure of variability would not change. All right, example 2, Yuki weighed several soil samples, each filling a 1/4 liter measuring cup. The distribution of the masses has a mean of 215 grams and standard deviation of 60 grams. After recording her measurements, she realized that she forgot to subtract the mass of the measuring cup, which is 20 grams. So I need to subtract 20 grams from every piece of the data set. So if I'm adding or subtracting, my measure of center will change, but my measure of variability will not change. So looking at that, which one is the measure of center? The mean or the standard deviation? All right, I hope you said the mean. So my mean is what's going to change. So I had an original mean of 215, and I'm going to subtract 20 grams from it to get my new mean. and I'm going to get 195 grams. So that's my new mean. What about my new standard deviation, or sigma? The old standard deviation was 60 grams, and remember, when I'm adding or subtracting, it does not change the measure of spread. So my standard deviation is actually still going to be 60 grams. I don't change it. All right, example 3 is difficult because we're doing 2 operations. We're multiplying and we're subtracting. All right, so it says a group of Americans participated in a study that involved taking their temperatures during exercise and extreme heat. So they had a mean body temperature. So remember, mean is measure of center, and standard deviation of 2, which is a measure of spread. Doctors analyzing the results prefer to work in Celsius. Annoying. So we need to convert the mean and the standard deviation to Celsius. All right, so if each temperature is converted to degrees Celsius, what will the new mean and standard deviation be? All right, well, the mean changes no matter what. So all I'm going to do is plug my mean into this formula. So my new mean is going to be all I'm going to do is convert it, because with the mean it changes with subtraction and it also changes with multiplication. So I'm going to plug my old mean, right, this is the old mu, into the formula, and we're going to figure out what the new mean will be in Celsius. So I'm going to do parentheses first, so I'll do 104 minus 32, and I get 72. I'm going to do 72 times 5 over 9, and I get 40. So my new mean is 40 degrees Celsius. All right, my new standard deviation is going to be trickier, because remember, my standard deviation only changes with multiplication and division. It does not change with adding or subtracting. So I need to look back at this and say the subtraction is not going to affect my conversion, because standard deviation does not change with subtraction. So the only thing I'm going to do is the multiplication piece of the formula. So I'm going to do 5 over 9 times my old standard deviation of 2. So this is my old sigma, my old standard deviation. It looks like a weird 6, sigma. I don't do the subtraction part because standard deviation doesn't change with addition or subtraction. All right, so I'm just going to take 2 and multiply it by 5 divided by 9, and I get 1.11. Can you see that? I don't see it. 1.11 degrees Celsius. So that's my new standard deviation. Remember, measures of center change no matter what we're doing. Measures of spread only change with multiplication and division. All right, so hopefully that helps you with the Khan Academy, the transforming data. That's what all of this is. All right, let's go ahead and do some practice AP problems to get you ready for the test. All right, students in AP Statistics were timed in seconds while solving a series of mathematical brain teasers. One student's time has a standardized score of z is equal to 2.4. All right, remember we just talked about z-scores, right? So z is equal to 2.4. I want you to tell me a few things about that. Is his time going to be above the mean or below the mean? I hope you said above the mean, specifically 2.4 standard deviations above the mean. All right, if all the times are changed to minutes, what will the student's standardized score be then? And remember, standardized score is just another way of saying z-score. So this is asking you what the new z-score will be if we convert everything to minutes. So I'll give you a second, and I want you to figure out what the answer choice is. All right, I hope you said D. It doesn't change. Remember, on this chart back here, our measures of location, our percentiles and z-scores don't change when we change all the underlying data. And that's because it tells us where that data point is within a certain distribution. So when I convert all the times to minutes, he's still going to be 2.4 standard deviations above the mean. All right, so z-scores don't change when we transform the distributions. All right, next one. A teacher is teaching 2 AP Statistics classes. On the final exam, the 20 students in the first class averaged 92, while the 25 students in the second class averaged only 83. If the teacher combines the classes, what will the average final exam score be? So this is testing your knowledge of, do you know how to calculate averages, or do you know what averages are? So go ahead and take a minute, think through this, and then we'll walk through it together. Okay, I hope you didn't just add the two averages together, right? So the class 1 average was going to be 92, and the class 2 average was 83. I don't know why I didn't highlight it. I don't know why I just stopped highlighting. All right. I cannot just add these two numbers together. They have different sample sizes, right? Look and see, in the first class, the N is 20. We have 20 students. And in the second class, I have 25 students. So I can't just add them together. That won't work. I cannot add these averages together. I'm going to have to back in to the sum of the scores. So remember, here's how we calculate averages. An average test score is going to be the sum of all the test scores divided by the number of students in each class, right? So I need to back into the sum of the test scores and add those together. All right, so my class number 1, the way I back into it is I'm trying to find the sum of the scores over my class 1 total number of students, which is 20, and equals my average score of 92. So my class 1 average scored a 92, and I had 20 students in that class. So to find out the sum of all the total exam scores, I need to multiply both sides by 20. All right. 92 times 20 is going to be 1840. All right, so this is the sum. I'm going to write it down here. Sum of class 1 test scores. All right, we'll hold on to that because we're going to use it in a second. Let's do the same thing for class 2. All right, how will I set up this class 2 equation now? My total of test scores divided by 25. Remember, class 2 had 25 students, not 20. And my average was an 83, not a 92. So to find out my total number of scores, my sum total, I need to multiply both sides by 25. All right, now 2,075 represents the sum of class 2 scores. All right, now that I have the sum of both the scores, I can add them together and divide by the total number of students, right? So my combined average is going to be 1840 plus 2,075 all over 45. Where did the 45 come from? It's my combined two classes. Class 1 was 20, class 2 was 25, so I've combined of 45 classes. All right, let's see what the new class average test score is when I combine both these classes. 1840 plus 2,075 is going to give me a numerator of 3,915, and I'm going to divide that by 45. Oops. And I'm going to get 87. Is that one of my options? Yes, it is. Option A, 87. So you see, I could not have just added the two together. If I added 92 plus 83 and took that number and divided it by 2, I get 87.5. That's not the right answer. 87 is the new class average. because I have different class sizes for class 1 and class 2. All right. Last practice problem. So practice free response problem. All right, so victims spend from 5 to 5,840 hours repairing the damage caused by identity theft with a mean and standard deviation. That sounds important. Remember, mean is represented by mu and standard deviation is represented by sigma. All right, what would the mean, range, standard deviation, and variance for hours spent repairing the damage caused by identity theft if each of the victims spends an additional 10 hours? All right, so if we spend an additional 10 hours, what are we doing to every single number in the data set? We're adding 10. All right, so we just need to go back to our chart and figure out what will be affected by adding 10 and what won't be affected. So remember, back at this chart, adding or subtracting, my measure of center changes, but my measure of spread does not change. All right, so let's figure out which one's a measure of center and which one's a measure of spread. All right, so my measures of center. Is mean a measure of center? Yes. Is range a measure of center? No. Standard deviation? No. Variance you haven't heard before, it's a measure of spread. All right, so my mean is my only measure of center, and remember my mean changes no matter what. So my original mean was 330 hours, and remember it changes no matter what, so I'm going to add 10 to it. So my new mean is going to be 340 hours. All right. Remember, my measures of spread do not change when I'm adding or subtracting. So my range, my standard deviation, and my variance will all stay the same. So let's go ahead and find these original numbers. All right, well, they give us the min and the max up in the problem, right? The 5 is the min, and the 5,840 is the max, and my range is not going to change, right? So I can calculate my range using my original data. 5,840 minus 5. So that's going to give me a range of 5,835 hours. All right, so that's my range. All right, my standard deviation they gave us in the problem of 245 hours. That doesn't change. Remember, measures of spread just stay the same whenever we add or subtract. All right, now my variance, you haven't learned this before. I'm just going to briefly talk about it, but we'll talk about it more in a second. The variance is the standard deviation squared. So all I need to do is square 245 to get my variance. Again, you didn't know this. I'm just showing it to you now. We'll talk about it later. So 245 squared is going to give me my variance. So my variance is 60,025 hours. So my variance is the standard deviation squared. Again, you didn't know that. All right, so we did all of parts A. Let's look at B. What would the mean, range, standard deviation, and variance for hours spent repairing the damage caused by identity theft if the victim's hours were increased by 10%? So when we increase something by 10%, we're going to multiply it by 1.10. That's how you increase something by 10%. So if I wanted to increase it by 20%, I multiply it by 1.20. If I wanted to increase it by 50%, I multiply it by 1.50. So here we're increasing it by 10%, so we're going to multiply it by 1.10. So let's look back at our chart. And it looks like when we multiply, both the measure of center and the measure of spread changes. All right, so we're changing all of them. So with part B, my measure of center is my mean. And my mean is going to change from 330 And we're going to multiply that by 1.10. And I get 363 hours. All right, my measures of spread. That's going to be my range, my standard deviation, and my variance. All right, so we calculated the original range, standard deviation, and variance, right? My original range is 5,835, and it will change. Measures of spread are changed when we're multiplying. So I am going to multiply that range by 1.1. So 6,418.5 hours is my new range. My standard deviation also changes, so it goes from 245, and we're going to multiply it by 1.1. So my new standard deviation is going to be 269.5 hours. And remember, I said variance was standard deviation squared, so I'm going to take this new standard deviation of 269.5, and I'm going to square it to get my new variance. So 269.5 squared. So my new variance is 72,630.25 hours. All right. That was a long free response, but for the most part it was pretty straightforward. It's just asking you, how do you transform measures of center and measures of spread. Measures of center always change, measures of spread only change if you're multiplying or dividing.